Welcome back to the hyperbolic trolling chamber. We are back once again. Today I'm doing a forehead reveal. You can see that my forehead has expanded. I have undergone a procedure to expand my forehead. Hopefully this will increase the square footage within my cranial cavity, and maybe we can stuff a couple of more LeetCode repetitions in there. But I'm waiting to hear back from my doctor about that. But before I even worry about that news, we have more important things to think about, and that is comments from one of the most legendary algorithms to live, part-time baseball player, algorithm, entrepreneur, visionary thinker, and author, Thomas Wong Coding. Watching LeetCode videos is kind of like revision for me. Same for me for making them. For me, when I look back over them, feels strong, man. Yeah, it's interesting. I don't look over them too often, but when I do, I'm like, oh, I remember doing this that day, and it was kind of the worst. So it reminds me of another thing where it's like you don't remember some things, you relive them. And when I'm watching those LeetCode videos, I'm definitely reliving the trauma there. So the LeetCode developers and the team over at LeetCode LLC, they'll be hearing from our lawyers, and the HCC and I are putting together a case to hopefully stop them from inflicting any more harm on the local programming populace. But if you're interested in hearing about the outcome of that or how we plan to do it, you should definitely join the Hyperbolic Coding Chamber Discord, where we are working on this very thorough document. And if you'd like your name listed, you should definitely join. I'm also joking, just in case. But yeah, that's kind of where we're at. I'm thinking I think I said yesterday, but for the rest of this week and the rest of next week, we're going to be doing slightly shorter sessions just because we're going to be starting a new Far From Home season. And yeah, it's just kind of the only way that the schedule works going forward. So hopefully we can make that make sense, and that will be the goal. So it's going to be lots of different types of LeetCode videos following after today, but they'll still be the same at the core. We're just showing up. So that is what needs to be done. I just ate a fat steak, so my body is diverting all the blood that usually or typically would be used for LeetCode problems to digest. So we're going to be working at 20% capacity today. Hopefully we can still do some work. So that being the case, there's not much else to say but to jump into it. So we're going to do a short 30-minute bangaroony. So yes, I definitely feel my insulin crashing, and I'm definitely seeing my eyes get slower, my mind's focus widening, my blood pressure rising, and my speech slowing. So we probably have at max 6 minutes of peak performance, and then the rest is just going to be autopilot. So let's see if autopilot can take us any further. I just realized we're going to have a problem because this problem we actually need to be outside of autopilot to solve. Alright. So you're given an integer array deck, where deck sub I represents the number written on the ith card. Partition the cards into one or more groups such that each group has exactly x cards, where x is greater than 1. And all the cards in one group have the same integer written on them. Return true if such partition is possible, or false otherwise. The max size of the deck is far too large for any sort of yeah, it's just too large. I want to say for any exhaustive group creation methods, but I'm sure there's some greedy version that will get us to a solution that makes sense. Here we have 1, 2, 3, 4, 4, 3, 2, 1. You can partition all the numbers into groups of size 2. So it looks like our current solution is to load all the numbers into a map, right? Figure out what the smallest count that we have for a number is, right? If the smallest group is equal to 1, right, that's illegal because the number each group has to have exactly x is greater than 1 cards. All right, so we return false. Otherwise, we iterate through all our occurrences again and we check to see if we have all odd, if we have an even, if we have all even. If we have all even numbers of groups, right, then we can return true. Yeah, I'm realizing now this doesn't even need to be here. If they're all even, you can return true. Otherwise, right, we either have all odd or even and odds. Number of elements remaining. If they're all odd, the best we can do is take the smallest odd number and see if it gives us any remainder remaining. Because the smallest odd number is the smallest amount of smallest way we can group the numbers. So I'm returning true for this case. Here we have 3 1s, 3 2s, and 2 3s. We should return false because it's not possible. It feels like we should just take awk mod smallest group does not equal 0 and return false. Smallest group is 2 though. So we should be, maybe with this version when we click. Yeah, I'm not sure how we're getting 2 here. Oh, we need to change this to for this to just run, right? The else case is that there's odd and evens mixed. If there's odd and evens mixed, we have to take just the smallest group and see if it scales up. If the smallest group is 2, it won't scale up, we'll get false. If the smallest group is 3, right, then we should be able to mod all of them by this, right, and get an answer. We don't need this case here. So we get to the last case where it fails. We return false, presumably because also we're not even using has odd and has even, so it doesn't even make sense to have these here. We're not even using all odd either. Similarly, we have a second. If we have a mix of odd and even, wouldn't we fail on the first case? 423 mod 3 does give you 0. 2130 mod 3 gives you 0. Which one of these mod 3 does not give you 0? It must be...
Electric vehicles are worth watching, and there's an EV that's right for just about every lifestyle. Head to SeenOnEV.com to learn more.
I guess we should probably know what the smallest group is. Unless it's already printed. Definitely is already printed. The smallest group is 24. Couldn't you rewrite this problem as finding the greatest common divisor for all these numbers? If you write this problem as find the greatest common divisor for all these numbers, if the greatest common divisor is 1 for all the numbers, then you have to return false. We want to find the GCD of a number. It might even be even simpler than that. If any of the numbers are prime numbers, no, the prime number wouldn't work because you could have 4 groups of prime numbers if there were that many of them. I think we just need to find the lowest common divisor, smallest common divisor. We have a function called LCD. We pass in a number, and we would return the divisor for that number, right? And the way we would do it is we would say for let I equals 2, I is less than or equal to num I plus plus. If num mod I equals 0, return I. If we never return anything, we'll return 1, because we know that that's definitely its lowest common divisor. At the end, I'm pretty sure we should be able to delete all of this nonsense and just do for const awk of map if LCD of awk equals 1, return false, otherwise return true. Well, I guess we should change it to less than.
Hey YouTube music listeners, with an Omen gaming PC you can do it all. You can be the always streaming, content creating, quick thinking, endlessly dreaming version of you. Powered by 12th gen Intel Core i7.
How much dislikes does this problem have?
More. Visit
Not that much.
omen.com/omen16.
I think we need there to be, if we had another map for every time we got the LCD of something, if LCD ever equals 1, we have to return false, which is true. Additionally, though, for the occurrence of LCDs, right, we're going to switch to something like this. If awk does not equal LCD awk. LCD awk. The occurrence of this common num mod awk equals 0, return true. Oh, it's called deck. We're gonna do this. If num mod 2 equals 0, we'll return 2. Else if, right, num now we can start at 3. It should prevent us from getting 1 anymore. This map is incorrect. The occurrences in the map are also incorrect. How do we have 3 1s? Oh, we do have 3 1s, 3 2s, and 2 3s. We need the occurrence of this LCD to equal the number of keys. The map's size is at least 3 elements. I'm trying to collapse all the even ones to I think we've been bested. Maybe we should just try and brute force it. largest awk or map.get num. Now for all these occurrences, I is going to be equal to 2, I is less than or equal to largest awk, I plus plus, pretty much going to delete everything. We're going to do for const occurrence in the map, right? If, so we're going to go through the whole thing, right? If
Electric vehicles are worth watching.
awk
There's an EV
mod
that's
I
about every lifestyle. Head to SeenOnEV.com to learn more.
equals does not equal 0, then we're going to break, right, and then go back to the top. If we ever make it to the end of the list of occurrences, right, then we'll return true. Right, if we break out of this for loop, yeah, that doesn't make any sense. We would just return true. Jeez. This problem is brutal. Somehow it seems pretty quick, but yeah, this is brutal. I tried to do some weird, I tried to do a bunch of optimizations, and then we end up literally just checking all possible occurrences, or all possible numbers that could actually be occurrences. And now I'm thinking we could have just, yeah. And then we just check over the entire, all the occurrences every single time, which is pretty awful time complexity wise. But I wouldn't even know how to begin guessing the time complexity on this. So maybe we'll try again tomorrow for better time, or we would check out the solution.